Hello, this is your Lakshma Reddy sir. Chemical kinetics topic. In this, few important topics are there, which are very important for JEE Advance, right? For NEET, main, you can expect this, but very less chances. But for advanced and for higher education, it is very important. Kinetics of elementary parallel path reactions. Parallel path reactions, or you can say side reactions, or you can say concurrent elementary reactions. What is the meaning of this? Sometimes in some reactions we get more than one product. For example, you are getting a product B, you say, and you say another product C, one more product D. A is giving you B, C, and D. And if the rate constants are given as K1, K2, K3, for example. Now, if B is major product, then C and D are minor products. In that case, K1 is obviously greater than K2 and K3. If K1 is greater, then product B is major. If C is major product, then K2 is greater than K1 and K3. If D is major, K3 is greater. Very simple logic. The reaction in which maximum yield of product is obtained is called major or main reaction. And the remaining reactions you can call them as parallel or side reactions. Here this is main reaction, major, and these two are parallel. If I take this condition, K1 is greater than K2 and K3, B is major, C and D are minor. Let's see some examples. We know C2H5Br, ethyl bromide when treated with KOH. There is a possibility of getting elimination product. At the same time, there is a possibility of getting substitution product. If it is K1 and this is K2. If K1 is greater than K2, means it is major product. If K2 is greater than K1, then this is major product. Depends. We know this reaction. For example, we have some X group here, which is ortho-para-directing group, and you are going for electrophilic aromatic substitution. Then there is a possibility of getting E at this place and at para place. So when these kind of reactions are happening, you can call them as parallel reactions, parallel path reactions. Okay, this is ortho, this is para product. If this is K1, you can call this as K2. Very simple. Nuclear reactions you can take, dehydration reactions you can take, ZGF product, Hoffman product will be there. Now, all those conditions you can apply for this. Whenever more than one possible product is there, you can apply this kinetics. Then kinetics. We will be discussing kinetics of parallel reactions. Very simple it is. Few important lines will take. For example, A is converted to B as well as C. This you can say R1. This is R2, rate of reaction. This is K1, this is K2, rate constant and rate constant. If K1 is greater than K2, then you can say A to B is major and A to C is minor. A to B is major reaction, A to C is minor reaction. Okay, you can enjoy some music also here. Fine. Now, let the concentration of A at a time T is A and if the concentration of A is A, then you can say regular. Come back to our first order kinetics. Let's take this is following first order kinetics. We know what is first order kinetics. Done. So R1 is equal to K1 into 8T concentration. Similarly, R2 is equals to K2 into A concentration at T time. And overall rate at which A reacts is, A is our reactant, is given as R is equals to minus dA by dt. This is very well known to us, which is equals to R1 plus R2. R1 is K1 A concentration at T time plus K2 A concentration at T time. Correct? Because only A, it is undergoing both the changes. For B as well as C, only A is undergoing the change. So overall rate with which A is reacting is R is equals to minus dA by dt. So for this reaction we have to check, and for this reaction also we need to check, that is R1 plus R2. R1 is equal to K1 into AT, R2 is equal to K2 into AT, that we are taking. So here A concentration of A is same, na? So K1 plus K2 into concentration of AT. This is your rate R. R is nothing but minus dA by dt. Minus dA by dt is equals to Ka, you can say minus dA by dt. Nothing but R. Nothing but rate is equals to Ka. What is Ka? Ka is overall rate constant. And here in this case K1 plus K2. If K3 is there, you can add K3 also. Look at this carefully. Finally we got minus dA by dt is equal to Ka, concentration of A at T. Remember this. Done. Now on integrating this equation, A naught by concentration of A is equal to KAT, or Ka is equals to 2.303 by T log A naught by AT, right? A naught is initial concentration, AT is concentration at T time, and we know R1 by R2 is equal to K1 by K2. dB by dt is equal to K1 concentration of A. dC by dt is equals to concentration of A T time, or we can say concentration of B at T by concentration of C at T time is equals to K1 by K2. So you can say K1 is equal to Ka into fractional yield of B K2 is equal to Ka into fractional yield of C. In this way you can find even fractional yields also. K1 is equal to Ka into fractional yield of B, K2 is equal to Ka into fractional yield of C. Generally you will be asked fractional yields only. Fractional yield of B is equal to K1 by Ka, fractional yield of C is equal to K1, K2, we are saying Ka. So this is all about kinetics of elementary parallel path reactions. What you need to remember is this formula. This is already known as Ka is equal to 2.303 by T log A naught by AT, and R1 by R2 is equals to K1 by K2. So dB by dt is equals to K1 into AT, dC by dt is equals to KT into AT. So concentration of B at T time by concentration of C at T time is equal to K1 by K2. Done. Important for IIT advanced type of exams only, not for NEET and main. NEET and main purpose, if you remember this formula, that is enough. Fractional yield of B is equals to K1 by K. Fractional yield of C is equal to K2 by K. And what is Ka? Ka is equal to K1 plus K2. This is like mole fraction beta. Very simple. Right? Thank you.